So what is the problem with comparable is, if suppose I'm dealing with 10 classes, 10 user defined classes, what I will have to do, I will have to go and change all 10 classes. Okay, and I will have to say that implements comparable, and then I will have to override the compare to method, and then I will have to sort it here. So instead of that, what is better with comparator is that we can implement comparator in the running class itself, like here itself, and I can work with whatever object I want, like with coder object or employee object, student object, any object, n number of object I can work together. Plus I can create some other class also which will implement comparator, do some sorting and give it to me. Okay, and I will simply execute it here. So that is the benefit with comparator. So I will not have to go and change the class. Okay, so here what I will do first, I will remove this comparable part from here. Okay, because if comparable is there already, the object will get sorted. Okay, so I will remove it from here. I will comment out this. Plus I will comment this compare to method also. Okay, so now I do not have comparable with me. Now again you see, the moment comparable is gone from here, again this sort method will start giving error. Okay, because obviously comparable is not there, so it will give error. Now what we will do, we will go here to the current class only. We will not touch the coder class now. Here in the current class only, I will say implements comparator. Okay, and the comparator will come from java.util. Remember, comparable is in java.lang, comparator is in java.util. Again here I will have to give a t type. Okay, so the t type is coder. After that, here I will have to add unimplemented method. So comparator also has only one method. Comparable also have only one method, which is compare to, which will take one argument. Comparator has one method, which is compare, and it will take two arguments, because here we are not comparing the current object. Okay, we will not compare other objects with the current object, rather we will compare two objects of the same class. Okay, so here let's say I will say coder C1 here and coder C2 here, and I will compare them. Again the comparison logic will be same. Okay, if they are equal, it will return 0. If they are, one is greater, it will return 1, otherwise -1. And the return type of this method is also nothing but integer. So let's say I will say int I is equal to C1 dot, see right now I'm comparing it according to CID, and here I will have to use getter, because if you remember, CID is private in coder. Okay, so direct CID we cannot access. See, here we can access direct CID and CNAME because we are in the current class, we are in the same class. But since the variables are private, which is a good practice to make the variables private, and I want to access it outside of the class, so I will have to use a getter. Okay, that is why the getters and setters are there. After that I will say minus C2 dot get CID. Okay, and I will return this I. After this, there is one more difference is there. See, now the sort one, I will not use the sort. See, we have seen the Java doc. There are two sort methods with, collections.sort. There are two methods. If you see, one is sort, which will take only list. Okay, and here it will take a comparable. Another one is it will take a list here and it will take a comparator reference here itself. Because now the object, the class which we are trying to sort is not implementing comparable. So that's why we will use this sort now. Okay. So what we will do here, we will go here and in this sort, now I will have to pass a object of the class which implements comparator. Okay, so that is our current class only which implements comparator, or else what you can do here, you can create another class which implements comparator and you can pass that particular class object here. Okay, so we will keep this thing simple and we will create here coder test object. Coder test, let's say coder test is equal to new coder test. Okay, because we cannot have a object of an interface. Okay, we can have only reference, but here we need a object. So this sort method will take a object of a class which implements comparator. So here I will give that object which is coder test. Okay, and it's fine now. My sort method is fine. And if I will execute this, again I will get the output according to ID, according to sorted, like coder object is sorted according to ID. Okay, so this is how you will work with comparator. Now, suppose if you want to sort according to name, that also you can do same logic as we have written in here in compare to method. Only difference is here we will use C1 and C2. So if I want to sort it by name, then what I will do, I will say integer I is equal to C1 dot get cname dot compare to C2 dot get cname. Okay, and return I. Okay, and if you see, it is sorted according to names. Again the same problem, since one name Diya is there 2 times. Okay, if you see in the objects, we have Diya 2 times. So what it will do in this scenario, it will get confused, it will maintain the insertion order. Again, if you want to overcome this problem, what you will do? If names are equal, you will sort them according to ID. So what you will do here, again you will write here logic. If names are equal, then obviously I will return 0, means the value of I will be 0. So if the value of I is 0, what we will do? We will say C1 dot get CID minus C2 dot get CID, and this will be I is equal to. Okay, so I's value will depend upon what ID we are using, and we will execute it, and there you go. Now when the names are equal, it will be sorted according to ID. Okay, so again if you want to sort it according to tech, here you can give C1 dot get ctech dot compare to C2 dot get tech, like that, and it will work.